my talk is about, so we just played Kahoot, right? So similar-ish app, it's a live quizzing application, and the promise we make is that it can handle up to 100K concurrent users, although in reality it's more like, we never tested beyond 32,000 users. That's the most amount of simultaneous players that have played that quiz app. So it's an app, it's a live quizzing app, multiple choice like KBC, and Ganesh talked about it earlier in his gamification talk. So the app is called Quizzup. It's a part of the whole Confab family of products. So the main goal of this app is, when you have a meetup or a conference or something like that, you want to keep the audience engaged during the break, just like we did with Kahoot during the break. Similarly, it supports both, people playing from in a room like this, or it can be completely remote. And we've had this app for about a year, and pretty much all our tournaments have been remote tournaments. Every Thursday and Friday evenings, we have quizzes being sponsored by companies like Microsoft. So, at the end of the 8 quizzes in the tournament, you get to win an Xbox or a Apple Watch for some of the other companies. Yeah, give it a try. The website is quiz.confab.com. About me, so I run a consulting business, so I'm a sort of a gun for hire. Do freelancing and consulting, mix of software development, software architecture, it's all over the place. I primarily focus on the Microsoft-centric technologies, so things like Azure Cloud, .NET, Angular with TypeScript. These are the things I know. So I offer CTO, architect, developer service, whatever you need. Pay for it and I'll do whatever you need me to.
No free trial.
Huh? Sorry?
Free trial.
Free trial. Well, play the app. It's sort of like a free trial. So I also build a whole bunch of products. So some people may know me through this CloudSkew app. It's a diagramming editor, somewhat similar to what Visio does, although it's only constrained to cloud architecture diagrams. So if you draw a lot of AWS, Azure, GCP, Kubernetes diagrams, so that's an online editor that you can use. Then this Quizzup, quizconfab.com, so that's the app that I'm going to talk about today. And a couple other apps that I am under NDA, so I can't reveal it yet, but soon when the NDA expires. So prior to this, I worked at Microsoft. I worked there for about 12 years. So I worked on Windows Server, the Common Language Runtime, Visual Studio, Azure Cloud. So I had like a sort of a journeyman career, like whatever excited me, I went and worked on that product. I'm active on Twitter, so that's my handle, Mithun Shanbhag. And that's enough about me. Alright, so this is what the Ganesh I think showed earlier in the day, but this is what the app looks like. There are quizzes which are part of a tournament. So tournament will have like 8 to 10 quizzes. You can go register for a quiz, and then you can see that there are 436 registrations, whatever. And the quiz is a live quiz. So Friday between 5 and 5:30, you can go and play it. So and then there is a quiz leaderboard. After the quiz is over, you can see it. So the gameplay is very similar to what we saw with Kahoot. It's a live quizzing app. So that's the landing page. So there this application is broken down into a couple of screens, if you will. So this is our landing page where you create your user profile, where you register for quizzes. And then we have, and then this is the quiz room where you actually see the questions and you pick a answer choice. And then we have like live YouTube chat embedded into it. You can, if you're running into issues, you can talk to the admin team and things like that. So you pick a multiple choice question, and then there's a timer that's running down, 30 seconds I think by default for most questions. You pick a answer choice, and there is a live, on the top right there is a YouTube live widget. So anybody who's the quiz master or quiz MC or whatever we call them, quiz organizer, they can do a live video as well. And then after that, you see the answer, whether it's right or wrong, how many people answered right, some statistics about the thing. So all of this is done in real time. So pretty straightforward, simple app. All of this is built on serverless. I mean, it's all built on Azure. It's all serverless. There are no reserved capacity anywhere. And we really don't want to get into the business of reserving capacity, and I'll get into why. Because these quizzes are only played a couple of times a week. Wednesday evenings, Thursday evenings, Friday evenings. And this quiz duration is like 20 minutes at the most. 15 questions and we are done. So there's no point reserving capacity for something that's used 45 minutes to an hour per week. So this is what our workload looks like. So it's flat throughout the week, but whenever you have quizzes, traffic increases 5,000x or 30,000x depending upon the number of users. So when the quiz is not happening, people are just using the landing page, they are registering for quizzes, they are creating a user profile. It's a simple landing page operation. But the quiz application itself undergoes usage only during those peak times, 5 o'clock on Thursday evening, 5 o'clock on Friday evening. And we see like 5,000x burst in traffic, and after that flat. So this is a textbook scenario for serverless. I don't see any point in reserving capacity when I'm only using it for a few minutes a week. So this is my API, which is on Azure function. So for folks who are not familiar with Azure, but know AWS, so this is Azure's equivalent of Lambda function. Lambda functions, whatever they call, Lambda triggers. Don't know what they're called in AWS. This is my database load, very similar-ish pattern. Only this is functions, this is the DB. So DB also we use a serverless flavor. It's called Azure Cosmos Serverless. So no reserved capacity. It just allows traffic to burst through during peak usage, and after that flatlines. And this is the WebSocket outbound traffic. So we, in addition to a REST API, we also transmit questions and the leaderboard updates through WebSocket. So whether you're playing from a mobile or whether you're playing from your desktop, there's a WebSocket connection, and this is the outbound traffic. So during quiz times it peaks, other than that it's flat. So the usage pattern pretty much dictates going to serverless. But what other guiding principles? So we use the microservices pattern. There's tons of microservices there, APIs, serverless database, queues, CDNs. Like everything is independently deployable, independently scalable. So this is a book. Everyone's probably read this book by Sam Newman, Building Microservices. So it's got some great examples. So all the principles from this book we sort of took it. If you don't have time to read the book, just go through this website called 12-Factor App, written by the Heroku folks. So it just tells about 12 principles of developing a microservices-based application. Like you use a centralized keyword store, or how to do rollbacks, how to use configurations, a bunch of things. The other thing is, this application is sort of on the bleeding edge of all Azure resource. It uses like this app is sort of meant for scaling. So you have to understand every single PaaS service that you use in Azure, whether it's storage accounts or web PubSub or database. You have to understand the limits, quotas, how much it will scale per subscription. So things like that. So is your storage account capable of egressing more than 12 GB per second? Like what are the hard limits? So you have to know those things inside out. There's a great link that I'm pretty sure even AWS has something similar, AWS GCP. But verification of link failed due to an error. Anyway, so the link, I'll send out the PowerPoint slide later. But there's a link there. You can look at. So this is what the architecture looks like. It's mostly Azure. There is a little bit of AWS thrown in there. And the reason for that is contractual reasons. ConfHub, the parent website for managing conferences and ticketing and all those things, was originally developed on AWS. Then Microsoft came along and asked us to develop QuizHub on Azure. So we had to build this child site, quiz.confhub.com, on Azure, and we had to marry it with the AWS component. So all the DNS entries, for example, are handled in AWS Route 53. So we just have to attach our CDN endpoints to Route 53. All the user pool management is done in AWS Cognito, so we just have to make sure that our stuff works well with AWS Cognito. But other than AWS Cognito and Route 53, everything else is in Azure. So let's walk through these blocks one by one. So you as a player will register for a quiz and you'll play this quiz either on your mobile or on your desktop or laptop, whatever. It's played in browser. We don't have a native app right now. Everything is played in browser. Then you load up the website quiz.confhub.com and then that takes you to Route 53, all the DNS records. So essentially these are all CNAME records that tie the subdomain name to CDN endpoint. And then we come to Azure CDN. So CDN, most of the assets that we serve out from the front end, like images or music files, they're all static content. So you might as well put them on a CDN there. So CDN will give you benefits like caching, compression, manage TLS certs as well. So the TLS certs I don't have to manage, I don't have to worry about when it expires. It's all auto-renewed by Azure. And also things like request response rewriting. So you want to attach a header to the response to enable gzip compression or something, you can do that through CDN. The CDN points to storage account. So this is like having your Angular or React application served out of S3 in AWS. So similarly in Azure we have static hosting that is enabled out of Azure storage accounts. So the application, the front end is React.js, and there are two applications, one for the quiz players, one for the quiz admin. Both of them go into storage accounts, and the storage account, so there is a storage account endpoint which is pointed to by the CDN, and this is the origin, which is storage account, in the storage account. So your application is served out of a storage account. So high level, when you go to the quiz.confhub.com, it's hitting Route 53. Route 53 will redirect to CDN, CDN will redirect to quiz.confhub.com, and all your JavaScript, CSS, music files, all those things are now loaded into your browser. After that, authentication, I'll get into authentication for a second. So all the API, so that's the front end side, these three pieces. Back end, everything comes through a gateway. So in Azure it's called Azure API Management, but essentially it's just a gateway. So things like JWT authentication is done here, rate limiting is done here. Things like caching policies are all set here at the gateway level. So all the requests come in, they are validated. The first thing any request does, whenever the app, backend apps wake up, they have to fetch things like connection strings, database connection strings, or host names or passwords, blah blah. All of that is kept in a secure key vault. So it's like a centralized key value store. So all your sensitive stuff is kept in there. So for example, when the request comes in with a access token, we have to validate it, but we also need things like the JWT authority, the audience. So that is extracted from the key vault, and then it is checked against the OpenID endpoint of AWS Cognito. So this is just to make sure that we are doing some token validation. The user is who they claim to be, and the JWT is whom it was intended for. So all of that information is extracted from Key Vault and checked against AWS Cognito. So once the validation check passes, then we have, for some data that is either expensive to compute or it changes very infrequently, we just stash that in Azure Redis, it's a Redis cache. So things like leaderboard, 20,000 people are playing the thing at the same time. So the leaderboard is like pretty large. So those are like really expensive to compute. And they only change every 30 seconds when the next question passes. Like between while a question is in progress, there's no point showing those micro updates. So we cache that leaderboard in the Redis cache. So that thing changes pretty infrequently after every question. So we just set the expiry to 30 seconds or something like that. And that infrequently updated thing is extracted from the Redis cache. So it doesn't even have to hit the API, and can just load it out of the Redis cache. For stuff that actually needs to, it's not cacheable, then we come to the API. So this is Azure Functions. So it's written in TypeScript, Node with TypeScript. Again, it's on a consumption plan, which means it's pay as you go. There is no reserved capacity here. Requests are queued. So you have a burst of, let's say, question comes, 20,000 people are playing, they all submit an answer. I'm not going to process all 20,000 in one go. I'm going to queue those requests into what is called as the Azure Service Bus. It's a fancy name for a queue. So comes into the queue, and then we dequeue this in batches of hundreds like that, and then we process the answers. So that is done by another this thing called Quiz Engine, which is another Azure function. And once the processing is done, it stores all the transactional results in Cosmos DB, which is like a MongoDB, NoSQL store. Again, there is no reserved capacity here.
Like all the messaging nowadays they use Azure and it is faster. Then why you went for that service bus?
Why did I go for service bus?
Yes.
30,000 people answering, I'm not going to. You have to, this is a pattern called queue-based load leveling, right? You have a burst of requests coming in. You have to process it in batches. The backend will not scale to like 30,000 instances.
Kafka also you can do the batching, automatic persistent do the batching already.
I could have used Kafka.
I'm just asking that reason, why you choose this?
Oh, because I'm familiar with Azure. Like and we have a what we call a sponsored plan, subscription plan from Azure. My decision making is pretty simple. Like it's like why did I choose this over that? I'm getting this for free from Microsoft, so why not use it?
If I'm a .NET guy, obviously I'll go for Microsoft.
And Microsoft sponsored this subscription. Like we didn't have to foot the bill for the first year, so. So if Microsoft has, if AWS had come in with SQS, we would have used that. Like I really don't have either or preference. So we stash all the things in our database, and then we also have to update the user that hey, you answered this question correctly, you answered this thing wrongly. 50% of the users, like the statistics we saw on code, 33% answered correct, 33% answered none of the above or whatever it is. So we have to, and that is done through WebSockets. So we have a what you can call it a trigger. So it's a trigger on the Cosmos DB. So or if you're familiar with Azure Cosmos DB, it's called a chain tree processor. So anytime an update happens in the database, we sort of wake up this quiz engine, and the quiz engine figures out what updates have happened, and then it transmits this through this service called WebPubSub, glorified WebSocket server. So and this WebSocket server will transmit the thing back to the user. So you get the updates on the screen saying that you have answered correct, 33% of the users have answered correctly, some people skipped the question, all that updates happen through the WebPubSub. So that is the high level building blocks. And then we have monitoring, telemetry, insights, whatever you choose to call it, and the CI/CD pipeline. So every time you, so there are two apps mainly, front end and the quiz application and this thing, the quiz admin application, and then there is one backend. So 3 pipelines totally. And every time you push into the main branch, it automatically deploys out to to the test instance, and then we manually promote it to production instance.
Question. You
Sure.
validate the answers before storing it to the Cosmos DB, or
So it's queued first and foremost. Anything that comes in gets queued, and then in batches of 100 we evaluate. So we know that okay, out of these 100 that I'm dequeuing, 83 are correct, 17 are wrong.
from an aggregation point of view, correct?
Mm.
Since apps give response very quickly, right?
Yeah.
For queuing, I thought it was validating just the answer right or
No,
wrong.
it definitely does validate, and the validation happens while the question is in progress. It is not displayed until the question ends, right? Because if I display the answer before the question ends, you can just create 2 user profiles, and from the first one you send a wrong answer, you figure out that it is the wrong answer, and from the second account you can pass in the right answer. So
Basically, immediately goes to the Redis. After that, you validate.
no, so the way it works is, let me walk back here.
Just to say that answer is right or wrong.
Yeah, so it comes to the back end, it comes to this web API, gets queued here, and then we dequeue in batches, and whatever the updates are there, it's pushed to Cosmos DB. At the same time, it's cached in Redis as well. So within that duration, so the what we call the eviction policy is for 30 seconds. So within that 30-second time frame, if you request that leaderboard, then you will see the cached instance, else it will go to the DB.
So when you are calculating that leaderboard every 30 seconds from the database, you are calculating and putting it into the Cosmos DB through a service.
Yeah, so it gets dequeued, computed, and pushed here, and then it also gets cached in the Redis cache. So there's way more slides than this. I'll talk about every single piece in detail.
How do you
question here.
calculate the time? I mean, whose time do you consider? Somebody answered in 1 second, somebody answered in 2 seconds.
Yeah.
So is it
All that is tracked.
the device's time or your server's time?
It's so we can't depend on the client time. You can spoof client time. So we consider the time at which the answer was queued on the server.
On the service bus.
Yeah. So that is for me, like, as soon as my API ingested it, that is the time I consider. So whoever's answer got ingested first, will, and if they answered correctly, they will rise to the top of the leader.
If the internet connection is slow, then it will.
It will take time. I mean, that's, I can't help it, right? If somebody's internet connection is slow, it takes time to DQ, to NQ it. Sorry man, get a faster connection.
This Redis, so should it not, I mean, this Azure function is my core logic, which is executing. So I think the Azure function should communicate to Redis. I mean, is it going via API management to Redis?
So in Azure, it is the API management has this thing called policies, and one of the policies is the Redis cache policy. So you can say that okay, this type of request, which like the response changes very infrequently or the response is hard to compute, just stash the on the first hit, just cache it in the Redis and let for the eviction till the eviction policy is not true for that 30 seconds, just keep extracting it from Redis. And once the eviction policy is done, the line item gets evicted, then it will hit the database. Actually, I have a slide to talk about.
So this is basically request level caching.
Sorry?
The Redis-
Yeah, request level caching. Correct.
Does the rate limit even make sense here because you have a dynamic?
Oh, we have people trying to they create 30, 50 accounts and then try to with one account they send one answer, another account they send another answer. So we have to have rate limiting mechanism. Like we are giving an Xbox away, right, at the end of the tournament, and people have tried to, write what do you call this, Fiddler scripts or Postman scripts, and they tried all sorts of things. So we need that rate limiting.
Size it dynamic?
Sorry.
Rate limit is dynamic?
Yeah, it's a policy again on the Azure API Management Gateway. So you can say that okay, from this one particular IP address, don't accept more than 2 requests per second or something like that. I forget the exact details.
So when the Cosmos changes to CDC, right, and after CDC, like you will recalculate the leaderboard things.
Yeah. So at the end of every, as soon as every answer gets processed, the leaderboard gets updated. But we don't show it until the question ends, right? That will give an unfair advantage.
So That is a WebSocket server, right? Last one.
Yeah, so it sends AES encrypted traffic back to the user. So they can't. Nobody can just you can use something like Fiddler and you can see the encrypted traffic, but you can't decrypt it until you have the key.
So that concept is only one way.
Yeah, it's one way. The users make requests through the APIs, but they get the response back encrypted through the system.
I think I was thinking, can we utilize for question answering as well, so that it will be much faster?
Sorry, I got distracted.
Can we utilize same way to taking question answer as well, so that instead of
Questions on your screen, the questions that pop up come through
utilize
comes through PubSub. The leaderboard updates comes to PubSub. Your position, your ranking comes to PubSub. So through the API, you just make requests. Response comes over WebSockets.
an individual question answer we can't.
Comes over WebSocket. Else, like people can send, write a postman script to request the answer or something like that. We don't do all that. So they can say that, hey, what is the right answer for this? And we don't. We have to send it through WebSocket.
What's the reason to use WebSocket and it's not a very continuous messaging channel or something?
Yeah, you need real-time updates, right? Like when the question is about to start, right? You want the timer 30 seconds, and after 30 seconds you want to display the leaderboard. So you can have a timer-based thing, but the timer, everyone's clocks may not be synchronized. So if you see the question first and then 10 seconds later somebody else sees the question, then you got an unfair advantage. To make sure that everybody sees the question, the leaderboard updates at the same time, we have to use the WebSocket mechanism. So that is one way to ensure that everybody's screen shows the question at the same time, on everybody's screen the question ends at the same time, the leaderboard updates are shown at the same time. So want to make sure that nobody gets an unfair advantage. So that is why you need WebSocket. If you use a timer-based REST call, then it's easy to spoof. Anybody with Fiddler or Postman can spoof that.
Regarding the SME, I'm interested in how many number of questions will be added. Is it kind of Excel sheet or manual way?
No, so you can import. We have an Excel sheet that you can import, and you can do. There is physically no limit on the number of questions. The answer, I think you are limited to 6 options per question. So you can't have more than 6 options.
Any plan wiki data, will take it and then some? No.
So, are you talking about the Azure, the engine which was there, 6 options?
No. Multiple choice, right? When you see a question, if I give you 4 or 6 options, if I give you more than that, you only have 10-15 seconds to answer. So I don't want the players to think which, I just want them to press a button. So minimizing the number of choice is better for the gameplay experience.
Why exactly they are using the Azure quiz engine? How is it separate from any
There's nothing special about it, it's just a lambda. It's serverless, that's it. It's just an API.
And this quiz is for only tech guy or
Anybody can play it. And see, our sponsor is Microsoft. And and there are a couple of other companies that are using this quiz platform for advocating their product or for hiring, the top 5 winners get a chance to interview at the company. So it's mainly a tech crowd, but there is no reason why you can't, you can do a simple math quiz, or you can do a science quiz, or you can do, literature quiz. It's a multiple choice question quiz answer engine, so can be used anywhere.
So
But
anybody can host it, anybody can host or?
No, you have to host it on our platform.
No, on this platform, is it?
Oh, can you create a quiz? Yeah, you can go register and you can create a quiz. But on the free plan, I think you can create up to 3 quizzes or something before your quota expires.
Where are you storing the questions and answers?
Cosmos DB. This part. Okay, so that's the high level architecture. Now let's dive into the scalability challenges. And this is where I spend most of my time. Okay. Players, they log in through their browser on mobile or desktop or laptop. There's nothing special here. Any browser will do. Route 53, did we have any scaling challenges? No. Handles scale immensely well. Azure CDN. Okay, so this is where it gets interesting. So Azure CDN, the Microsoft standard plan or tier as it's called, will only support caching and compression if the file size is less than 8 MB. So you have to make sure that the JavaScript files or any music wave files or whatever you're loading into the browser has to be less than 8 MB, else it won't get cached. So if you are using a React application, then one of the things you can do is you can chunk the file. If you are using an Angular application, you can lazy load the modules by breaking them down and only loading it when that module is actually called. So this is, I don't know if this is visible to everyone, but you can see that the file is broken down into some name.chunk.js, and we've intentionally kept the file size less than 8 MB so that it gets compressed. And in the header, response header, you can see that content encoding is BR, broadly compression, which compresses it to 40% of its original size. So to get that, you have to ensure that size is less than 8 MB when you are using Azure CDN. So, and you can break that down by using chunk files or lazy loading. So that was one thing we learned the hard way. Second thing is, people tend to refresh their browser for whatever reason. Like for example, on your mobile, if you just slide your thumb down, it automatically refreshes the thing. So we didn't want to send a network request every single time somebody accidentally did that. So what we did was we set the cache control header. So the Azure CDN allows you to rewrite the request and attach headers, or you can change the method body, you can change the protocol from HTTP, HTTPS. It's pretty flexible. It has a URL rewriting engine. So we use that to set the cache control header on the response. So what this cache control header does, so we set the cache expiration to 1 hour. So if you load a JavaScript file or if you load a static image, it is served with cache control header max age 3600 seconds. So that means it stays cached in your browser. So even if you refresh that thing, even accidentally, it doesn't do a network call, it loads it back from the browser cache. So there's no outbound network request. So now you can see that if I accidentally refresh the page, the transferred column is all cache. And the latency for loading that file again is 0 milliseconds, because it's loading from the cache, it's not sending an outbound network request. And the cache control header says public, which means any public browser can, you can cache it at CDN level, you can cache it in the browser. Max age is 3600. It will be cached for an hour. And that's good enough. So that's the tricks with CDN that we had to discover the hard way. Okay, after that we were good with the CDN. Storage account, we didn't really have any issues. The default ingress, egress rates, like the band, the capacity can easily serve more than 100K users, so we didn't really have any issues there. And plus we keep the file sizes small and chunked, and we cache it, so there's not too many outbound network connections that are happening. So egress is also very limited, so we were good there. API management, okay, gateway policies. So pre-flight requests, like everyone's familiar with pre-flight requests. So it will send an options request to see that whether the API is actually handling it or not. So and that, if you cache the response, if you cache the request, that's generally good, because you can set a gateway policy that says that pre-flight result max age is 3600 or 5 minutes. So instead of it sending multiple pre-flight requests, it uses the cached response, saying that hey, in a window of 5 minutes, we've already validated the pre-flight request, so we don't need to do it all over again. So we just use the cached response. So it just prevents the number of outbound calls. So this is better. So we cache the pre-flight.
Developer without SLA or? APIM is developer without SLA or which plan?
We are using the consumption plan. So again, no reserved capacity, it is pay as you go. So if you, I think that it comes like the first million requests are free, and then after that your the metering starts. So here we see that access control max age 300. So in that 5-minute window, if you send a pre-flight, the browser sends a pre-flight request again, like it's sending the options, it's just going to get the cached response. So that saved a lot of outbound calls.
Was this a pre-flight request too?
So pre-flight request is, if you are using a put post or something, the browser will generally, and it's behind JWT validation thing, so the pre-flight request will, it's a browser's mechanism of figuring out whether the API is capable of handling. It's a part of the core's policies, right? You can say that only requests that are coming in from this origin or from this method type, like only get requests or post requests, they are supported. So the pre-flight is just to figure out whether the server is capable of responding back to that request.
An options call.
Yeah, an options call. Yes.
And one more question. Like in a development stage, like are you using without like as you said, like consumption, like in a
So
production?
we have two mirror environments. The dev and test are absolute mirrors of each other. The only difference is in the key vault, the connection strings differ. So in the test environment, so the same app, same code base, it's just deployed into two different environments. So the first thing it does is self-bootstrapping. It wakes up, it talks to the key vault. In the test environment, it will get the test database string called test service bus, all those, and in the production, it will get the production version. They are identical to each
During
other.
the production, you move to consumption or like in a
Both are consumption. Both are consumption. There is no difference between. So we didn't want to deal with Heisenberg, right? Like something under test is the condition under test is different from condition under in production. So sometimes if you have that, if you're using a 300 DTU database in test, well, here you're using 5000 DTU, then some bugs will only replicate in test and not replicate in prod. So we didn't want that. We wanted them to be identical mirror images of each other. So it's the same, what we call Pulumi script that deploys both of them. The only difference being the key vault values. Another thing, there's a heavy burst of traffic when people are answering questions. So logging, right, like what we call the information level logs. Request came in, request was stored in the database. Like that is, we don't want to overwhelm the API gateway. So we set the sampling to 95%, and this is again by trial and error. So I don't need to know that 100 people's request came in, it got logged. That trace message I don't really want it. So by reducing that sampling rate to 95, so we reduce some pressure on the API gateway. So in Azure, there's this thing called sampling percentage. Just don't set it to 100 if you are a high traffic website. Set it to 90, 95.
The pre-flight requests, it happens for everything, authentication and questions.
It depends on your core's policy, right? If your API sets a core policy that I will only accept requests coming from that whitelisted set of IPs, or only something that has a specific header, or something that only calls one specific, like get, post, put, patch, whatever. So only support one specific subset. So the access control header, so to test that, it has to send a pre-flight request. And if the API says that I don't know what this pre-flight request is, I'm not handling it, then the browser will suppress all further calls out. So pre-flight is just like a canary type of a thing where it will say, this API is capable of handling this kind of method from this origin.
And this APIM logging and then Azure monitoring logging, what kind of
No, it's all Azure monitoring. Every monitoring, every trace goes into Azure applications insight, which is a part of the Azure Monitor family. So, the APIM doesn't have its own monitoring facility, it piggybacks on Azure Monitor. So, once we do all these two things, API management side, we are good. Then comes Key Vault. Key Vault, no challenges at all. Cognito, no challenges, scaling challenges. Redis, okay, so this is where things get a little interesting. So like I said, cache your most expensive calls. For us, computing that leaderboard live is very expensive. 30,000 players at the same time, we want to make sure we are giving the live updates. So we cache that. So we cache it for a duration of 120 seconds. And here you can see that when the response comes in, if you for some reason don't want it through the WebSockets, if you want to get it through the API. For example, on the landing page, right? On the landing page there is no WebSocket. You are not playing the game. You just want to see the leaderboard while a quiz is in progress. So at that point we send it as a response, and the max age is 120 seconds. So in that duration of 2 minutes, if anybody asks for the leaderboard, the first hit will be loaded from the database. After that, for a duration of 120 seconds, it's serving the cache data. So by doing this, we ensure that the hit rate, cache, the cache hits far exceed the cache misses. If we didn't have that, because we have hits far exceeding misses, our DB spikes get narrower. If a lot of the things were cache misses, then it would peg the DB for a while, right? If it has to load every request from the DB, then the DB utilization is going to get pegged. But only the first one gets loaded from the DB, everything else for 120 seconds comes from the cache. So your DB axis pattern changes now. It's now, instead of being a very broad spike, it becomes a very, very, very narrow spike. So you are seeing that, those are all like 2 minutes, the spike is for that, first hit in that 2 minute window will go to the database, everything else, it falls down and then it just loads it from the cache.
Wouldn't you do it at the first request only and every other player will always see the cache?
Yeah, it will be, see, that is only when you are looking at the landing page. The thing that is sent through the WebSocket, we only send it, we have this thing called as a hub. So we just send it one thing to the hub, and the hub will transmit that copy to multiple players. So there we don't have to worry about this. This is only for the REST calls. No, generally, if like 30,000 players are playing, you'll have like a good 10,000 people who also have the landing page open in a separate thing, and they're just checking just to see if they can get some unfair advantage while the quiz is going on. So we have to cache it. Okay.
How do you find out about this pattern that people open to sessions?
Telemetry. I'll get into it. Yeah.
So how often do you refresh the cache? Let's say that it comes, when you say that it comes from the this request needs to be refreshed at some point.
Yeah, so we have something called as an eviction policy. So once an item goes into the cache, it stays alive for 120 seconds, and after that it is evicted out.
It's after 120 seconds, every 120 seconds it gets evicted out.
Correct. I mean, if a new request comes in and it's not in the cache, then it has to load it from the DB. But once it's loaded from the DB, it gets cached for 120 seconds. Okay. Alright. So now comes the three things: the APIs, service bus, and Cosmos. And of course, the four most challenging things. Okay. So we are on a consumption plan, which is a pay-as-you-go. This is horizontally auto-scaling. Okay. So Azure functions. Now I don't know how many people are familiar with Azure, but I'm sure Lambda or Google Cloud Run, GCP Cloud Run all have some similar things. So there are three kinds of plans. So there's a consumption plan, which is auto scale based on traffic or rate of incoming requests. There is a premium plan where it's similar, but you can have one pre-warmed instance. So one instance will always stay warm, and depending on additional load, it will spawn out newer instances. So that is event-driven scaling. You can also have this thing called as a dedicated app service plan where you can reserve some capacity, but that doesn't support event-driven scaling. So there is some, you have to specify your own rules declaratively through JSON, or you have to slide slider and say, oh, I want 3 instances of this, I want 5 instances of this, or you can go, do some JSON-based rules that says that on 5 p.m. every Friday, scale it out to 5 instances or 10 instances. So for cost reasons, for keeping it extremely economical, we go with the first one, event-driven consumption plan. So we completely let the Azure scale controller decide, what conditions you want to scale it out. We are happy with it. So and that's the cheapest. Premium plan starts at $150 a month, and we need to hit some revenue goals before we can get to premium. App services again pretty expensive and doesn't support event-driven scaling, so we decided not to go with it. So we have event-driven consumption scaling. Now the way this works in Azure Functions, and I can't draw apples to apples comparison with Lambda, but you pack your functions, your what do you call, like the event-driven workloads. So those are called as functions. You pack multiple functions in an app, and then you deploy it to Azure Functions. And the unit of scaling is not the individual functions; it's the app. So let's say you pack 20 apps together, 20 functions in an app together, and when the thing scales, you get 20 plus 20. So you have 2 instances, now you have 40 functions. So you have to make sure that whatever you're packing together in an app can scale together. So if you have 10 things that are calling into the database, and now you have 3 instances. Now instead of 10, now you have 30 functions all hitting the database. That's a bad way to scale it. So you have to separate out the HTTP triggered functions from the queue based functions, from the timer based functions. So this is something we learned the hard way. Initially we just had everything packed into one function, and when the requests came in, 30,000 requests started coming in, it scaled it out to 40 instances, and then you had 40 copies of the function all hitting the database at the same time. So the ones that were doing the database operations, we isolated them in a separate function app, and then we had to limit the scale out to only 3 or 4 instances to be able to handle the DB load. So unit of scaling are apps, not functions. The only caveat is the service bus triggered function. So there, if it's a service bus triggered function, then the functions can individually scale, doesn't need the app to scale. Again, something we discovered the hard way. Functions that can't scale together shouldn't be in the same app. One of the things you want to do is enable this thing called as a scale controller log. Now again, this is a consumption plan. So Azure platform completely decides when to scale it. So if the incoming rate of request queue is more than 200 requests per second, then it will scale it out to another instance. So there are some rules to that. Those rules are opaque. So sometimes you have to debug those things, like why is my DB pegging? It's because you have 40 instances that are scaled out. So you have to enable something called the scale controller log. So in Azure, it's a key value pair that you specify in your configuration. So once you do that, the Azure scale controller log starts getting emitted into App Insights. So this is what it looks like. So here you can see that some traffic went down, so it scaled it back in from 1 instance to 0 instances. So you can see how many instances of your app are actually alive. So this is great for telemetry and diagnostics, otherwise it has no other practical use. Timer trigger hack. Now I don't know, this is something specific to Azure Functions, but people try to use the event-driven, the consumption plan, and then they keep a timer trigger, try to keep the app warm. So, it's consumption. So if there's no consumption, it will scale it back into 0 instances. But people try to work around that by having a timer triggered app that fires every 1 minute or something and does some activity like console.out or something.
That's the logging. That's the logging.
So people try to use, the premium plan comes with 1 warm instance. But if you don't want to pay $150, what people do is they create this timer trigger thing. Every 3 minutes it will fire, or every 4 minutes it will fire. It will do some activity to keep the app warm. But now the platform has gotten a lot smarter. So now they detect all that. So now even if you fire the thing every 30 seconds, it will still and sees that there is no actual usage. It's just timer triggered thing. It will scale it back into 0 instances. So that hack doesn't work anymore. And I figured this out only after looking at the scale controller logs.
Are you sure, like, we can literally take the whole URL and generate a random?
Here's the logs don't lie. So here's a case where, my timer trigger fired 9:30, like 9:30, 00 and 9:30, 11. So 11 seconds after my timer trigger fired, I was scaled back in from 1 instance to 0 instance. So that hack doesn't work anymore.
So basically, let's say that if there are 100 URLs, using random number generation, you are basically rendering some random pages.
Okay.
Azure what detect that? Like, mostly, I guess. Like basically, what we are trying to.
So the basic thing is, if it is not real usage, if you are just trying to simulate usage to keep the app warm, it's not going to work. They detect the patterns.
It's like a DDoS attack. It's very difficult to differentiate between actual traffic.
So, see, I mean, the options are simple. Either pay $150 for a pre-warmed instance, or have actual traffic that is coming in. So these time and trigger hacks will no longer work. Okay,
Anyhow,
so
for Azure, right? It's billing for them. Why they are making it here?
sorry,
For Azure, it is billing for them, right? It's uses.
they have to pay developer salaries somehow, right? So, they can't keep offering free services.
Creating a custom request
Mm.
function. So it should allow when they are stopping.
Take the premium.
Take the premium, pay for the premium and you get one pre-warmed instance. So if you want everything free, you want everything to be free, then why is Azure even supporting?
No, it's not free. I will get that.
The first million requests are free.
Yeah.
So,
I think you typically get charged for a number of API requests, right?
Right.
Very small instances.
Okay, what happens in DDoS scenarios on a proper web application? Basically, what happens that Cloudflare gives you like one-click access to protect everything.
yeah.
So how does Azure can you talk about?
No, there is Azure Firewall. I see our application is like the revenues are not that high enough that I can justify putting in like a industrial grade firewall. There's a built-in firewall available with the scale controller. So if it sees a pattern where people are sending in synthetic requests, trying to DDoS start rejecting. Plus we have rate limiting also. So there is an industrial grade firewall as well that will do deep packet inspection and all that. It's way more expensive. So I have not reached that level of profitability where I can justify putting in that expensive service.
How much time did it took to create the whole?
2.5 months, I think.
Mithun, I have a question. Mithun, for Azure function, there is a 2-minute timeout for consumption plan, right, for the computation?
5 minutes for consumption, extensible up to 10 minutes through
10
the
minutes.
functions
Did
JSON.
you ever face that challenge with Azure function?
No, most of our event-driven workloads are pretty short, right? You answered a question, now you have to check against those 4 choices, and you immediately know whether it's there. So the heaviest computation that we do is every time there is an update that happens, you have to update the quiz leaderboard. So 30,000 people on the leaderboard. You answered a question right. Now you moved from position 80 to position 17 or something like that. So that rearrangement of the array is sort of like the heaviest computation we do. But even those things, 5 minutes is way more than enough to.
Any reason to use TypeScript? Does it follow stack very well?
See, this TypeScript by itself doesn't matter. It's running inside Node. I mean, to be honest, I didn't dig that deep into things like pre-jitting, and I just let the framework handle it. So there is another thing here called as warm-up trigger. Okay, so let me talk about this. So here is our P99 latency for one of our API calls. Okay, so you can see that most of the traffic is getting served within a latency of 550 milliseconds, half a second. But then there are some requests that are taking up to 6.8 seconds, and this is again leaderboard computation. So those things are taking a long time. Why was that happening? So we dug into this telemetry here. So the first thing is the API gateway, which calls into the Azure function, which calls into Cosmos DB. So there is this long latency. So every time the app scales out, it has to establish a connection string to the DB. So the on-cold start establishing your DB connection takes time. So it took sometimes up to 4 or 5 seconds for that DB connection to be established. But once that DB connection got established, you can see that very quickly it returned the response. But the establishing of the connection was problematic. Now the answer there is, use something called as a warm-up trigger. So every time it scales out, new instance is created, it will incur cold start, but there is a warm-up trigger that you can wake it up with. So when it scales out, it will scale out with a warm-up trigger, and the trigger can be like a DB connection. So it will warm up the app so the app when it scales out, it's available in a warmed up state. So that again is available with the premium plan. So once we hit our level of profitability, we'll go to that plan. But we are still living with this issue right now. So P99 latency, most calls will finish within 400 milliseconds, but there are some outliers that just take a long time. Just have to deal with it.
That full end-to-end is app inside.
It's all app insights.
Compared to that last one, Cloud Scheme, all the things are like app services, and then now we have Azure functions. What is your take?
No, even Cloud is now on Azure Functions. I've long moved it to Azure.
So what is your take call on that? Cost-wise, like how much according to your experience?
So right now for all this, right, the most expensive component is Web PubSub and Redis Cache. We pay around $140 to $160 a month for the entire dev plus test. Cloud Squid is more like $40. I mean, there's no like burst of 50,000 users using it at the same time.
No, I'm comparing like other functions we are using, and so cost-wise, like how much it is.
I mean, see, it really comes down to your workload. I showed you the workload, right? Only on Friday 5 p.m. and Thursday 5 p.m. I have spiky workload, so there's no point for me to use non-serverless.
No, if we have an app service and cost us like too much.
For this application, I don't need app service. I don't need to pre-reserve any capacity. I want to be completely pay-as-you-go.
So this event is for the whole infrastructure?
For your whole infrastructure.
Whatever the cost you said, is it with free services or without free services?
No, with the free services also. See, the major cost is the web socket thing. And there is still some optimization we can do there. I haven't fully explored it, but right now we are paying around 140 to 160 depending on how much the usage is. So the major cost is for the web socket, and I think that comes to around $85 or something. The Redis cache is another $35, and rest of the stuff is like pretty cheap. Service bus, I think we use the queues and topics, so we use standard, so that's $10. So ultimately, when you add everything up, it comes to around 140, 150.
Including API.
Including API gateway, including functions, including Cosmos DB, including CDN, including DNS, including Key Vault, everything together is.
Have you compared it with other providers or not?
It's free. It's paid for by Azure. Like 140 theoretically. Practically, I'm not even spending a single dollar because it's a sponsored subscription from Azure. But yeah, we have limits on how much we can spend. So we get credits for $150 a month or something like that. So we can't just jump to the premium plan because that itself is like $150, $155. So our bill will go to $300 or something, and we don't want to spend on that.
Any security incidents observed?
In telemetry, we do observe a lot of attempts to, like multiple people playing simultaneously, people trying to synthesize JWT tokens, and we all catch all that. And it's not 100% foolproof. Like you'll have a script kiddie who, with all the time in the world to crack it, and they do our testing for us sometimes. So.
Because of that, cost will increase, right? That's why.
No, I mean, we can use things like, like the DDoS detection, industrial grade firewalls and things like that. But again, this is not a Facebook or a Google with like millions of users. It's small, so it's okay.
How it was load tested? How the application was
Some external agency, we hired them to, they did some JMeter based testing. But the best load testing is like actual Friday evenings. The max, I think like some 32,000 players have played at one time.
How much do they charge for load testing?
I will look at the bill and I'm not really concerned. Like I'm a developer, man. Like I don't care.
Actual testing happens in the
ask Ganesh. I don't know. Like Ganesh paid the bill. Like I don't really involve myself with all this. How much the bill was.
For security, any services like I just want to know like any services you're using, like how is it managed?
I mean everything is Cognito has its X-ray logging, and this one has its Azure Monitor logging. So just have to. We set up dashboards, we set up alerts and all that, and we'll get to that. But yeah, it's just a combination of those two.
So you have to speed up.
Sorry?
You have to speed up.
Oh, okay. Sorry, we're running out of time. Yeah.
Webshop is the function that you use. Did you face any data loss?
No.
How are you?
No, that handles retries, resiliency, everything is. It has its own rate limiting policies and stuff like that, but so far, no. We haven't. Okay, we have to speed up. Service bus. So thing we realized that we queue everything. We don't want to dequeue it one by one. We want to dequeue it in a batch and process that way faster. So we use batch triggers. Now we DQ 100 at a time, so we have to make sure that those 100 things are committed in one transaction. So we use this unit of work transaction commit pattern. And then we tweak the host JSON setting. So this is essentially a fancy way of saying that I want to DQ 100 answers in a batch. I want to have 32 concurrent batches, blah blah blah. That is declaratively possible. So for this quiz engine, we suppress the scale out limit because we don't want it to arbitrarily. It can scale up to 200 instances, and we don't want 200 instances hitting the database simultaneously. So for this one, we suppress the scale out limit. Then Cosmos. Cosmos has this thing called capacity calculator. So your leaderboards are, end of the day, they are nothing but JSON documents. So JSON documents, depending upon the rate of incoming requests, the size of the documents, how many properties are indexed. So you have to sort of like estimate how much capacity is needed. Will something cause a denial of service if it exceeds that capacity? Remember that link that I had shown earlier about scale out limits and quotas. So there are quotas around like per collection, how many how many request units can go in on a document, how many concurrent writes can happen. So you have to be cognizant of all those. You have to be cognizant of hot containers. So if you're familiar with Mongo, it's called a collection. In Cosmos DB, it's called a container. So we have this whole lot of collections, and some collections are way more running hot, disproportionately hot compared to other ones. So in our example, it is the question and quiz leaderboard. While the quiz is going on, like we are constantly updating the question leaderboard, the quiz leaderboard. So those two tend to run hot. Rest of the stuff is like pretty, like it's flatline. So we have to be aware of that. So when you have hot containers, never use dedicated containers, never use shared DB throughput. So if your throughput is at a DB level, it can't distribute the throughput, equally. It tries to distribute the throughput equally amongst all the collections, which is not what you want. You have disproportionately hot containers, so you want to redirect most of the throughput there. So instead, use for the hot containers, use dedicated throughput there. Don't raise your throughput too high. So we did this mistake once where before a quiz, like 20 minutes before a quiz, we raised the throughput so that we were anticipating some 20,000 users. We raised the throughput, and then we realized we can't scale it back down to its previous level because it retains memory. So you can only scale it back down to 10%, like 10% of what it originally went to. So if you raise it too high, you can't come back to the previous one. So this is something we have to discuss. And then we have to like delete the database, or rather migrate the database to a new database and set the throughput all over again. Other than that, serverless tier, we use the serverless tier. It has limitations, so there are caps at container and partition level. So for example, per container, max RUs per container is 5,000 RUs per second. So you have to make sure that you do things to drop the capacity consumption below that. So there are some tricks for doing that. I'll get into that. One of the drawbacks of the serverless tier is there is no regional replica, so we are sort of living with that limitation. Everything is in central India right now. But when this thing becomes more popular, we'll think of solutions. Large documents, again for the leaderboard, we are we make sure we drop most of the things from the index, so write commits become easier. They consume less throughput. We are not querying by those properties. I am not saying, hey, show me user number 83 or user number 27 or user who's in position. We don't query, so you can drop it from the index. Okay, what else is there? Okay, Cosmos DB. Materialized views in Cosmos DB need, so essentially we have what we call as, every time there's an update to the DB, we want to send the we want to send the leaderboard to the user, saying that hey, something has changed. So we use change field processors. Putting those change field processors or triggers will actually increase your DB consumption because it's constantly monitoring. Every 500 milliseconds or a couple of seconds it's monitoring. So that query will. So here you can see that it's pegged at 5,000, like 500 RUs or something. So this is happening just because of that trigger. So this is something again we realized the hard way. So we had to increase the feed port delay. So rather than checking every 500 milliseconds, maybe check every 1 second or check every 2 seconds. So if you increase the feed port delay, the consumption starts going down. So we had it at 600 milliseconds. We were checking to see, hey, has something changed within this window duration? It didn't. It was pointless. So we changed that to 3 seconds or so. Triggers will add scale out pressure. So because of that Cosmos DB trigger, now you can see that unnecessarily it is getting spawned out to 40 instances. So we had 40 instances of the app running concurrently, and you had the DB trigger which was causing the scale out, and each scale out again queries the DB. So we sort of ran into that hockey stick problem where this is I think on quiz number 1 or 2 we had that, and we had to suppress the scale out of it. So the quiz engine scale out, we had to limit it out to like 1 or 2 instances. Point reads again. So people familiar with Mongo, you have to horizontally partition your load. So you have to make sure that you are doing point reads. You specify the partition and row key. So when you directly know the partition and row key of the document you are fetching, the throughput consumed is very less. But if you don't specify that, or you specify a range for the partition, it does scan the entire DB or the entire, or do what we call as an inter-partition scan. So those are expensive. So you have to limit that. Web pops up. This is my living nightmare. So depending upon the number of users, we have something called as a scale unit. So if 1000 users are, by default it supports 1000 users. But if you are anticipating more than that, you just have to slide it out. There is no auto scaling for this one. You just have to estimate based on the number of registrations that, okay, there are 30,000 people who are registered. So it means that max 30,000 people will play. So just sort of slide it out before the quiz. So auto scale is unavailable, so you have to slide it out manually. Reserve capacity only. Once you slide it out, you start paying for the whole hour. Connection quota we have to keep an eye on. So every time you slide out, this is capable of serving 20,000 users, so we have to see how much capacity is actually used. But the biggest problem is not the number of connections, it is the message sizes, the message frequency, the rate limiting, or this is the math behind it. I think we should come to that picture because I couldn't figure it out. This sort of requires a PhD in math to estimate the bill. I gave up after a while. So there's still some work that I have to do to optimize, like how many messages can I send in a group, what is the message size, with what frequency I should transmit the message. And if I properly optimize that, then maybe my bill will drop down from $85 to maybe $40 or something. Just haven't figured it out right now. So yeah, still some work to be done here. And what else is there? Telemetry, again, we have this dashboard, which shows all the telemetry coming in real time. So we can see like the number of dead lettered messages on the service bus, exceptions that are happening, warnings that are being raised. So I can see all this in real time, but really, you'll do this the first 2 times. After that, you want to set up alerts because you don't want to be staring at a dashboard forever. So we have set up automated alerts. So it will notify us when something goes.
Availability section. Availability section.
Yeah, not just for availability, it's also for things like throttling, hitting rate limits, or somebody trying something malicious. So we have what we call as Kusto query language. We can query all those patterns and raise an alert. So we raise a simple Slack alert. And this is something called as an application map. So this shows you the hotspots in your application. So for example, in the front end, the call to Cognito is in a different region, it's not in central India. The application is in central India. People are all over the world. The Cognito, I think, is in Singapore or something, so the latency is a little high. But this sort of gives you a good visual cue of what is a bottleneck. Then again, this latency graph. So we look at P95 and P99 latencies. Cold start we talked about. And finally, there is a DevOps piece of it, which is, we have 3 pipelines. One which deploys the front-end app, the front-end quiz app, the front-end admin app, and the back-end apps. So 3 in this range. So you can see that there are 2 environments who are mirror images of each other. There's a production environment and a test environment. Each of those have 3 applications. So that is it. And if you want to work on this, send out an email to teachers at Console. I guess we are hiring. So it's fun work. So questions?
So when you are using Cosmos DB and you benchmark it for 100K users, so did you face any consistency?
I didn't benchmark it for 100K. The max is 32K users.
Live traffic, right?
32 live actual users.
So did you face any consistency issues or anything for which you...
The reason it is 100K and not 150K is because WebSockets will not scale beyond 100K simultaneous connections. If you need more than 100K, then you have to get a second subscription. So per subscription, the limit is like I think like 10 scale units, which is capable of 100K simultaneous users. I can scale beyond that, but just the engineering behind it gets a little complex. We cross that bridge, I don't have, right now the average usage is like some 8,000 users per quiz. So why prematurely optimize?
So, but when you are coming to that scale, you have to think on all those things, right? Read-write logs that are happening on the database and all those. Have you already managed those or you are waiting for traffic?
I am a person who solves things just in time. When I have the problem, I'll solve it. I don't believe in prematurely optimizing for problems I don't have.
Like in the messaging, how can you handle the back pressure in this?
I am not. I'm doing a terrible job of it, right? Like, so like I said here in this. This is still a cause for concern. See, all these things like optimizing group sizes, message size, message frequency, outbound traffic volume. It's a mess right now. Just haven't had the time to deal with it. So it's working now, but it's not optimal. So
instead of using PubSub, if we use the Node.js stack,
so the thing is, see, I don't want to reserve a server for this WebSocket activity. I'm playing the quiz 15 minutes on Thursday, 15 minutes on Friday. So I just dispatch it to the WebPub server. The WebPub server, does the thing with like maintaining client connections, maintaining the resiliency, retries, all that, rate limiting, it handles it on its own. This is how to specify the
PubSub is what, notification hub or?
WebSockets, high level.
Mithun, one question.
Azure.
Yeah, it's a.
Yeah, even I was
Event-driven notification of
It is a glorified way of saying WebSocket connections.
So no, that underlying technology is fine.
WebSockets, raw WebSockets. On the client side, we just use the WebSocket APIs from JavaScript. We don't have to import any SDK or anything.
Have you thought of implementing AMS or Nirvana?
Sorry?
Basically, asynchronous message broker instead of a PubSub.
It is a synchronous message broker. I just dispatch to it and it dispatches within some latency threshold, it will dispatch it. So it will say that once I receive the message from the application, from the backend, it will dispatch it within 10 milliseconds or something. So that guarantees
Have you thought of any other software like AMS or Nirvana? Do that.
Free Azure subscription, what's available with Azure, we used it. I'm sure there are better, more optimal solutions available for this. Just haven't had the time to.
Which optimizations you have done when you faced the problem or?
Yeah, again, all of these things we come to know about from telemetry. On day one, we telemetrized the application, front end, back end, everything, and we just started observing patterns. So, and then we see that, the DB pressure is spiking, then we go fix it. And we saw that, okay, service bus, the dequeuing is happening too slowly. Then we increase the batch size, we increase the number of concurrent instances. So, everything is telemetry based. When the data is there, only then we act on it.
So the business logic and the statistics, that 33% rate, so that is written in the quiz engine functionality.
Yeah, the quiz engine, the leaderboard calculation, the evaluation, all is done by the quiz engine.
Wouldn't you use a cache instead of a database? Instead of storing it into a database, can you not use an in-memory? I know it's free.
In-memory means now you have to pay for this thing, right? These are short event-driven workloads. 500 milliseconds later, it is dispatched off. So I don't want to have an in-memory storage. So we just use the Redis task of it.
I'm not sure about this completely, but like anyway your Azure Web PubSub is reserved capacity only, right?
It is, yes, that is one place where we have to use reserve capacity. So we have to reserve the scale unit. So if 10,000 users are registered for the quiz, then we have to make sure that 10,000 WebSocket connections can send outbound traffic. So that is one part where we have. There is, unfortunately, Azure doesn't yet support a pay-as-you-go model for horizontally auto-scaling it out. So,
Why not, you already know like what is the time duration when you have the traffic, right?
yeah.
So why not spin up like your own implementation of this?
We are a 2-person team. I'm handling the backend, one other person, and we don't have all this energy for DevOps, so we just want to use what's available. So.
This telemetry, the software telemetry you're talking
This is built into Azure. So Azure has this thing called Azure Monitor. So essentially you can send out traces from your application. Plus for any of the PaaS services that you use, it automatically logs all the incoming requests, response, request bodies, response bodies, latencies, everything. It just automatically tracks it for you. It's a little expensive, but yeah.
So initiating this connection for the website.
Sorry?
That application who is initiating the connection
So there are two things to that. So the player who's playing on the mobile or laptop, so there is one connection there, and then there is also like we from the backend have to dispatch to the web proxy. So as soon as you load the quiz, go inside the quiz room to start answering questions, we use the WebSocket SDK to establish connection with the WebPub hub. And clients and the WebPub hub makes sure that it's a resilient connection. So if the connection drops and then it comes back up, it will reconnect and it will handle everything seamlessly.
So Mithun, I have one particular question. Incognito is, the Cognito is giving you, he's the issuer of the identities.
Correct, ID and access tokens, yes.
So that's sitting in AWS.
It's sitting in AWS.
How are you securing the browser to Azure Web Sub? How are you securing that?
Which one? So
from that mobile
user logs in.
Yeah, user
logs in, gets a JWT. So we use authorization code grant. So we send it through TLS traffic to the backend, and it's served.
Are you using that JWT to establish?
Yeah. So if you observe, there is a authorization bearer header.
And you're giving that
Yeah. So and then what happens is once it comes to the API gateway, it will fetch the JWT authority and audience from the key vault and check it against the Cognito, OpenID.
Or you could also keep the certificates right there.
I mean, just haven't. We developed this in like a rush.
Second thing, this 30,000 users on one message hub.
So far it has scaled.
Yeah. Third thing, you will be having one more connection. Oh, you told about it. Did I hear it right? That you have a connection from the Lambda function. So from the Azure function, you have one WebSocket that is connecting over there.
No, we just use the SDK, Azure WebPub SDK, and through the SDK you do the dispatch. And then it handles storing it, distributing it across message groups, sending it to like a cluster of clients. All that is handled by WebPub. That's opaque to us.
Excellent.
Key. Because on the client side also we have to have that key to decrypt it. And you are putting.
If I tell you this, then it's a good question.
You are putting that key inside your front end code.
No. And I'm not going to tell you that because we had a couple of hacking attempts around that. So people would try to take the minified JavaScript and try to break down the JavaScript file to see if they can find the key. They try to see if we can patch the key. The answer, I'm not going to give it away. Okay. The key comes in an AES.
I'll ask you in person.
I'm not going to tell you. That is my secret sauce.
I'm struggling with that to implement in my own application.
So the answer is
the security is a big challenge because the first thing is the very important.
We are doing triple AES encryption. So
on the client side itself.
You have to decrypt 3 times.
Blocks.
So how is the security on the WebSocket?
All AES encrypted traffic. So so even if you use something like Fiddler or Postman or something, you can't see the unencrypted traffic. You need to have the key. You have to decrypt the key again. You have to decrypt it 3 times to get the actual content. and we get the 3 keys from 3 different places which only I know about. That's my secure mechanism.
So you use any open source?
I mean, all whatever is available on Azure, like all the Azure SDKs. I don't think, I mean, most of the Azure functions is open source. Web PubSub, I believe, is open source. Redis is already open source. I didn't care.
Why? Because security incidents normally happen there.
No, we haven't had any, like, we've detected attempts, but we never had any incidents.
So this AES encryption that comes built in the PubSub, or you have to build that?
By default, PubSub has an encryption mechanism, but we wanted something custom. Like, we didn't want to use the Microsoft managed keys, we wanted to use our own keys, and we wanted to double, triple encrypt it. So we decided we can extend that. We can piggyback on the default thing and we can extend it. So that's what we did. Okay. So feel free to try it out, quiz.confirm.com. Every Thursdays and Fridays we have quizzes. So when you want to win an Xbox, Apple Watch, have at it.
How likely is that? How likely is the price?
So this is our 4th or 5th quarter, and every quarter we've given away an Xbox. So very legit. So
we got this gamification session, right?
Right. Thanks, folks. If there are any more questions, I'm available here, so we will connect offline. Thanks again.